Hi folks, we're in Mod 5 again, and we're doing problem number 5 now. This problem we will be doing in Excel Miner, and it's a problem that asks us to do something that is fairly common in business, is to classify something. What we're going to do is take some credit approval data and create an algorithm, a rule, by which we can make a determination whether someone receives credit or is rejected. And we're going to do this all visually on a graph. So let's take a look at our data. Our data is here, and there are, I think, 50 records. Yeah, 50 records. We have information on the homeowner, on a credit score, years of credit history, revolving balance, revolving utilization, and decision, whether they were approved or not. So let's do as the problem asked. Let's first of all create a scatter diagram in Excel Miner, and let's make the credit score the y-axis and the revolving utilization the x-axis. And then we're going to color the decision. This is like adding a third dimension to our data. And we can do this also in our Excel graphs, and we can do it easily with Minitab. In a later video, I will show you how to do that if you don't have Excel Miner. So let's go to the Excel Miner platform. We know that in Explore we have our chart wizard. Let's select a scatter plot. I'm going to have to get the data that I want. I have preconditioned the data because I want two columns. I want the credit and the revolving utilization. So I cut that out of the data that I had over here, cut and paste, and removed the other variables. I have the decision variable also over here, which I will use. But let me grab all of the data. Scatter diagram. Next, it asks me what my y-axis is going to be. The y-axis was going to be credit score. I hit next. It asks me what my x-axis selection is going to be, and I pick revolving utilization. It says, do you want to color a selection? I do. I want to color decision, because we have two decisions, reject or accept. It asks me about a panel. I don't want a panel. Hit finish. And here's the graph that I get. This graph is kind of hard to see. One of the reasons it's hard to see is because Frontline has made an effort to let people know that if you make a presentation with this software, you're using it as a result of this educational software. So they're protecting themselves. You know, who can has a problem with that? I mean, I can understand that. But it's annoying because you get this watermark in the middle of your graph. So here's our graph. Here's revolving utilization. Here is credit scores. And the blue represents approve, and the gold represents rejection. And we want to be able to draw some lines, as the author did in the book, both vertical and horizontal, and one with slope, that we can say on one side of the line we're accepting or we're approving the loan, on the other side we're rejecting it, whether it be horizontal or vertical. We can see that there's a high relationship between higher credit scores and lower revolving utilization, which leads to the blue, which leads to approval, and lower credit scores and higher revolving utilization, in other words, indebtedness, leads to rejection. Makes sense, right? So how do we build a graph like this? Well, the way we do that is we take this graph, we copy it, and we paste it into our Excel sheet. So I copy, and then I go over here and I paste it. I'm going to discard the original. Here's what I've just pasted. and I can work with that graph. Here it is again, sorry. I can work with this graph and then add lines and do whatever I need to do. If I go to the Insert menu and I go to this little set of tools here that represent shapes, I can find lines. There's a line. I can draw almost vertical line here. I can move it around. This is how I'm going to select my my heuristic and say anything above this is approve, anything below is reject. You can see that I have a problem with these two that are accepted that were actually rejected in the original data. So there's a bit of an error. You know, I can also put in another. I can make a copy of this line, and here it is, and I can change its inclination, change the slope to make it a vertical line as opposed to a horizontal line, and then I can play that game again and say, okay, where do I draw these lines such that I can make a rule that says anywhere to the left of the line I'm going to be approving, anywhere to the right I'm going to be rejecting. And I've done that in this. I'm going to get rid of this for a second. And I'm going to show you the graph that I created before. I've done that here, and you can see here's my my vertical line. That's the first one that I'm asked to do. When I draw this vertical line at this point, it's hard to see some of these values. For example, there's a little yellow dot there. If I move this line to the right as far as I can before I hit this larger quantity of yellow, this one is misplaced. So in the rule that I have here that would suggest that anything over 0.46 or something like that in the revolving utilization, I say anything over that is going to be rejected, anything of that will be accepted. For the purposes of approval, I make one mistake. And then for the purposes of rejection, I also make one mistake in that rule. That's reflected here in this. In the answers here, I selected 0.425, and it's the midpoint between these two regions. You'd have to make that decision yourself. If you want it further out, you want it to be a little larger than 4.25 or a little less than 0.25 for approval. Less is more stringent, higher is more relaxed. And you can see that the predicted classification for approval of the 23 values that were approved, 22 fall into that rule as approval, and only one falls out. And of course, that was this value here. For the decision to reject, there are 27 rejections, and there's only one value on this side that rejects as a result of this rule. So one approval and 26 rejects when the decision is to reject. The way we do our calculations for performance, we say take the total of the possible outcomes, which are 50. We have 50 records, and divide the number that are problematic. When I approved, I should have rejected. When I rejected, I should have approved. So add these two together and divide by 50, and I get 4%. The same thing happens with the vertical. Where do I draw the vertical? Well, this point right here is, I think, 0.642. So anything above 642, I'm going to say approve. Anything below, I'm going to reject. What I wind up getting is no problems with the approval. That's the lowest one. There's none of the values that fall below this value, and but I do have two values that should have been rejected that fall into that category. So I've got these two rejections out of the 27 rejections that are a mistake, no problem with the approval. Then finally, can I draw another line? And here I just pick a line that I think is convenient, and I draw it through this particular point and this particular point. Say anything below this is going to be rejection, anything above is going to be approval. And of course, there is one problem that occurs because this one, it was an approval and it should have been a disapproval according to this rule. And so I get one problem that occurs here, but none with the rejection. So that's 1 out of 50. That's 2%. I ask which is the best rule, and of course, this rule with the smallest percentage leads to the best percentage. But of course, it depends upon the sample that we look at, that we're examining. You'd want to do this with a fairly large sample to create a visual rule. Anyway, very simple way of doing this. Later I will show you how to do this with Excel. A little bit more difficult because you have to be innovative with the scatter diagram and also with Minitab. That's the end of problem number 5 and module number 5.